Okay. What is it? Sorry, yeah. Have we done this one? Tutorial 2? Have we done this one? Why look like I did before, but it does not conform? This one we done already, is it? 1, 2, 3, 4. Oh, okay. So, okay. So we will talk about the integration now. We will continue the integration to finish the integration first lah. Okay, so this one just normal integrate lah. For example, you want to integrate this one. Okay, with respect to t, you just take your I as a constant. Okay, you just take your I as a constant. So how are you going to integrate it? So 3e it, and then what you need to do is you have to divide what is inside there. Okay, and then don't forget everything you have to 0 to pi, and you put inside 0 to pi and then see what happens. That's all. Okay, so the next example also the similar. Okay, integrate of z squared dz. In the square of z squared dz way over the control of z equal to t plus ti. Okay, so how we're going to do with this one? So you have to take note, the t is 0 to 1. Normally they will tell you the t is from way to way so that you can integrate from starting point into the last point. Okay, and then your z square is what? Your z square is t plus ti. So change your z into this one because what you have is z square dz. This one is with t. So you have to change everything into the t. Okay, this one still simple. Z square you just substitute with t plus ti. Okay, and then what you need to do is you have to substitute the dz into the dt. So how are you going to do that? So I know that z is t plus ti. So what I need to do here is I differentiate both sides. So I know that my dz, okay, my dz will be 1 plus I dt. You just differentiate with respect to t. Okay, differentiate with respect to t. Okay, dz dt will be 1 plus I dt. So you put in your dz as 1 plus I dt. And then the rest you just normal integration with respect to t, then you will get the answer. Okay. So this one I also don't want to talk much. So next one. Okay, so now if I want to integrate this one, fz dz. Okay, so where it is a C1 and C2. So what is C1 and C2? So here, okay, fz is real z, yeah? Fz is real z. So okay, I need to find out what is my zt first. Okay, I need to find out what is my zt. So from C1, C2, that means combined together will become C. Okay, so now it's only we want to deal with C lah. Okay, so when you deal with C, okay, so 0, 0 into the 1, 1. Okay, 0, 0 into the 1, 1. We need to change it into the parametric equation. So what is mean by parametric equation? So what you have to do is, okay, you have to do okay, how you going to do okay, we separate to two sides x and y. So what happened to your x? Your x is from from 0, 0 to 1, 1. Okay, so it will be, let me think a bit. 1 minus of 0 plus 0. 1. Y will be also 1 minus 0 of t plus 0. Okay, why this one? Okay, it will be the last point. Okay, when you look at the x, okay, when you look at the x, the last point minus the initial point and then plus the initial point. Okay, then your t will be something in between 0 and 1. When it is 0, then you will have 0, 0. When it is 1, then you have 1, 1. Y also the same. The last point minus the initial point times the t and then plus the initial point. Okay, so this one will be the parametric equation. But you have to take note, this one I get t. This one I also get t. Okay, but you have to take note, now your zt should be x plus yi. So x plus yi, so I t. So that's why we have here. Okay, when you take out the t, okay, where it is a 0 to 1, and because I only want the real part, I only want the real part, so that means I only take the t. Okay, so I only take the t, so my x here will become the t. And then what is your dz? Your dz, okay, your dz you differentiate from here. This one you differentiate with respect to t. You will have 1. Sorry, okay, what you have differentiate with respect to t1 plus I dt. So you have to substitute this one into your dz here. Okay, 1 plus I dt, and then the rest is just do the normal integration. Okay, so this one is if you do it in two way, C1 and C2. So you have to do the C1 first and then you do the C2. Okay, so what we can have a look here is C1 is from 0, 0 into the y does not change but the x change, so become 1, 0. Okay, so your y is equal to 0, so no need to do to deal with the y. You just deal with the x. So what is your x? X will be again the last point minus the initial point. So times the t, so I get t, and then plus the initial point, so plus 0. So x is equal to t. So that means your zt is only x because your y is equal to 0. Okay, you try also, you will get y equal to 0 lah. Okay, 0 minus 0 t and then plus 0, so you get 0. Okay, so what is your zt? Your zt is only t. So the rest will be the same. Okay, you just put in the real part, which is the t, and then your dz will be dt, and then you do the normal integration. Okay, C2 also the same. C2, what is different is now it is from 1, 0 into the 1, 1. So your x will be 1 minus 1t, so 0t plus 1, so 1. Your y will be 1 minus 0t, so 1t, and then plus 0, so only t. Okay, so that means your z is what? Your z is t plus it. Sorry, 1 plus it, because your x is 1. Okay, so the rest will be the same lah. You differentiate it, and then your t is still 0 to 1. Okay, 0 to 1, and then what is your real part? Because it's still real part. Okay, the real part, what is the real part? 1. Okay, so it should be 1. And then what is your dz? Your dz is I dt. So you have to substitute your dz with I dt, and then you just take this one and plus this one together. Then you will get the answer. Okay, so you have a look. For this one, your C is although we know that, okay, C is combination of a C1 and C2, but because this is not analytic, so that's why you see this one and this one is not the same. Okay, one is half plus I, one is half plus half I. So it's different there. Okay, so that's why they said real Z is not analytic. So that's why, okay, your C is not equal to your C1 and C2 combination together. Okay, so this is what they found lah. Okay, can you try to do the questions five first? Question 5, 1, 2, I left it to you. And question 6 also. I think questions, let me see. Yeah, you just do the question 5 and 6 first. Try to do it. Okay, so I finish lecture first. Okay, so we will continue. So let's say this one. Okay, I want to. Where is it? Oh, this is another different. Is it? Okay, so just now is not analytic. Okay, not analytic. Then okay, you will get different answer. So now let's see if it is analytic. Fz equal to z. Okay, Fz again we do C and then we do C1 and C2. So yeah, I don't mention I don't brief I don't set I don't teach how they do lah. Okay, this one just normal like just now lah. But what is different is now my function is changed, become the z. Okay, so I get I for C and C1 and C2 together I also get I. So basically when it is analytic, your z is analytic, then you no matter you separate to how many paths, okay, as long as the initial point and the final point is the same, then you should get the same answer. Okay, so this one also the same lah, which is when they are analytic lah. Okay, as long as their first point and the initial point is the same, then you should have the same answer. Okay, so this one we try to evaluate. Okay, 3z squared AB where the point is 1 1 and 5 3. Okay, so 3z squared is analytic. Okay, so no matter what path, as long as it's 1 1 to 5 3, okay, you can direct from 1 1 into 1 into 5 3. So what you do, you just take the x is what? 40 plus 1. Okay, so 40 x is 40 plus 1. Why I don't saw that? AB is straight line. 1 plus I, how come? Yeah, okay. 40 plus 1. Okay, and then your y will be 2t plus 1. So 2t plus 1. Okay, so this one will be your I. So that's why they try to separate into the constant and the t lah, so that the differentiate you directed the 4 plus y only. Okay, so just normal do the z, you find the zt and then you find the dz and then put inside your what is your z and then what is your dz and then you just do the normal integration. Okay, because this is analytic, so we don't care what path it is. Okay, if it is not analytic, it depends on the path. Okay, that should tell you which path they use. Okay, so this one. Okay, residue. Residue will be another things. Okay, so what is residue? So by definition, what is residue? Okay, let's say I have the complex function f. Okay, analytic must be on the analytic and positively oriented. Okay, positively oriented simpler clause control and its interior I except at z equal to z naught. Okay, except this point. Let's say except this point. Then the residue of f. Okay, then the residue of f at this point, okay, at this point, so at this point is denoted by res f z naught. Okay, is f z naught or residue of z equal to z naught at fz. So how we're going to find it? It will be the formula of 1 over 2 pi I and then integrate. Okay, this one means clause lah, clause control lah, fz dz. Okay, but just do like just now, just normal integration fz dz. Okay, so this is how we're going to find the residue. Okay, how we're going to find the residue if the complex function, okay, your f, okay, has a simple pole at z naught. If you still remember what is simple pole lah. Let me see, where is simple pole? Yeah, this one. Okay, for example, how we're going to find the simple pole of this one? So we make this one, this one is we have to combine them. Okay, we have to combine them and then we make this part equal to 0. This part equal to 0, so I have z equal to 0, z equal to 0, or z equal to 2. Okay, so z equal to 0 will be a simple pole because it's power of 1. Z equal to 2 will be order of 5. Okay, pole of order of 5. So this is how we're going to find the pole. Okay, so we go back. So that's it. Okay, if you have a simple pole, okay, if you have a simple pole and then hz itself is not equal to 0 and g is analytic at z naught, okay, g prime is not equal to z, that means your g prime is not equal to 0, okay, then your residue is what? Your residue will be this formula, okay, z naught fz, where your fz is hz divided by gz. Okay, so this one will be your sorry, this one will be your residue. Okay, which is h z naught g prime z naught. Okay, so later we'll see. Okay, this one is when they have order of m, then your residue will be this one. Okay, so we'll have a look for the example. 1 minute. Sorry, 1 minute. My handphone no battery. Okay, so okay, so this is the example. 1 over z, the simple pole is at z equal to 0. Okay, at the z equal to 0, so it will be h z naught divided by g prime z naught. Okay, divided by g prime z naught. That means what? H z naught. That means your 1 is still 1. So it will be 1 divided by g prime z naught. So this is your g prime. So differentiate become 1. So 1 over 1, I get 1. Okay, or you can do like this also can. Okay, this is by this one lah, by this way. Okay, so now we have a look. This is the second one. If you have this one is the same, or this is when you have a simple pole. Okay, this is when you have the simple pole. Okay, so now this is an example. Now we have a look on the example. I want to find the location and type of singularity. That means we want to find where is the pole. Okay, and then what is type of the pole? So this one z squared plus 1. So we make z squared plus 1 equal to 0. I get z equal to plus minus I. Okay, positive, negative I. So plus minus I. So this one will be my simple pole because this one is power of 1. Everything is power of 1. Okay, so power of 1. So this is a simple pole. Okay, simple pole. If you want to find the residue, okay, if you want to find the residue, so what you have to do, since this is a simple pole, then you can use either this one or this one, up to you. Okay, so what we do, if you use the first one, so it will still be Ez. Sorry, okay, it will become Hz naught. Okay, Hz naught divided by G prime Z naught. If this is a simple pole. So Hz naught, what is Hz naught? Is still the same, Ez. But you have to put in, let's say I take they take the negative I first. So it will become E negative I. And then you differentiate here, will become 2z. Okay, 2z and change your z into the negative I. So E negative I divided by negative 2I. Okay, the rest is just because what we do here, we change exponential into the normal form of the complex form. Okay, and then divide by 2I, then I have this one. Okay, so this one is when it is I. So now it will become EI and then 2I. Again lah, just change to a normal complex form, then you will get the answer. Okay, so next one, the question 2. Question 2 is cot z, cotangent z. Okay, cotangent is what? Cos divided by sine. So sine z equal to 0, that means my z will be n pi. Okay, my z will be n pi. So now, again, this is a simple pole, okay, because this one is power of 0, power of 1. Okay, power of 1, so this is a simple pole. So what is the residue? Again, cos z divided by differentiate of sine z, cos z also. So no need to care what is your z, because cos and cos cancel each other, you get 1. So that means your answer will be 1. Okay, so this one is normal simple pole. Normal simple pole. What? Z equal to 0. Oh, let me see. Okay. How come? Oh. Okay, so what they do here is they're trying to differentiate it. They're trying to not differentiate. They're trying to cancel each other. Z, this all the okay, so they left the only Z here. And then this one become 1, this one become power of 2, and then power of 4, and so on. Okay, so that's why they have the simple pole when Z equal to 0. Okay, so when Z equal to 0, let me see. Yeah, okay. They can say this one become 1, and then the rest is power of 2, power of 4, and so on. So this one is no more. Okay, only left the Z here. Okay, why they don't cancel each other? Because this one you will get 1 over something. Okay, so that means now this is your function of hz, this is your function of gz. So when you differentiate, it will become 1. This one, when you differentiate, no need to differentiate, but this one you have to put here. Okay, so z equal to 0, so this one whole thing will be gone. Only left 1 here. Okay, so it will be 1 divided by 1. So the answer will be the answer of 1 here. Okay, have a look. Okay, so I'll continue again. Okay, so this one is cos z divided by z squared and then z minus pi. So now I have two, and I have two poles here. One is z squared equal to 0. So z equal to 0 because it's power of 2, so this is a double pole. Okay, z minus pi, so z equal to pi, this is a pole of order 3. So for double pole and pole of order 3, then I cannot use this one anymore. I cannot direct use this one anymore, okay? Because this one is for simple pole. So now I have to use this one. So I have to differentiate. So one, for example, the minus the double pole, I have to make my m equal to 2, okay? So it means I have to use the formula of that one. So okay, so this one is double pole, so change your m into the 2 minus 1. Okay, and then because this one is a double pole, so you only need to differentiate one times, and then you will get your answer here. Okay, this one is a bit longer, but it's still the same concept, just you have to differentiate one times first. Okay, so this one is, because this one is order of 3, so now change your m into 3, and then you have to differentiate for 2 times, but the rest will be the same. Okay, but you have to differentiate for 2 times, so seems much longer. Okay, have a look. Okay, let me see. Okay, so we continue. Okay, so Cauchy residue theorem. Okay, Cauchy residue theorem. Okay, so this theorem is talking about what? Okay, this theorem is talking about if a complex function f is analytic and positively oriented, just like just now when you find the residue, okay, then if you want to find the integral of fz dz, then it will equal to 2 pi I of you plus all the residue together. Okay, so that means you just need to find the residue and then you plus together and then times the 2 pi I. That's all. Okay, so for example, I want to use Cauchy residue theorem in order to evaluate this trick. So let's see the first one first. So first one, again, we try to find the pole first. So quite clear, z equal to negative I is a simple pole. Z equal to negative 2i is pole of order of 3. So I need to find the residue of these two. And then plus together times the 2 by I, then I can get the answer already. Okay, so but you have to know lah, you have to have a look. Any positively oriented simpler clause control enclosing z equal to negative I and z equal to negative 2i. So is inside, these two is inside. So you have to find the residue of these two. If it is not inside, then you don't need to find. Okay, so now we have a look. So we have to we found the simple pole and then the pole of order 3. Okay, simple pole of order 3. So I need to find the residue of this one. Since this is a simple pole, so what you need to do, you just direct the EZ, and then what you need to do, you differentiate this one. Okay, you just differentiate this one, or you do the limit, you find the limit also can, because not necessarily must use this formula. Sorry, not necessary to use this formula. If you think this formula is difficult to use, then you use this one. Sometimes you use this one will be much easier. Okay, z minus z naught and then hz divided by dz. Okay, so for here you will see for this one, okay, so z minus z naught because it's negative I, so z minus z naught it will become z plus I. And then times this one, so this one and this one will be cancelled. So you only left this part. And then you put in your negative I, then you will get your answer. So sometimes this one is much easier. Depends on the what is your GZ. If your GZ is difficult to differentiate, then you use this formula. If your GZ is easier to differentiate, then you can use a HZ divided by the G prime Z. Up to you. Okay, but this is only the Z minus negative I. You still have to find for the Z equal to negative 2I. So this is 4. For the 3, then you have no choice. You have to differentiate for 2 times. And your M now is 2. Okay, so you will have, 3. 3 minus 1, I get 2. Okay, so you differentiate 2 times and then you get the answer here. Okay, this one how to differentiate, just normal integrate lah, normal differentiate lah. Okay, you take it as u and v, and then v dx minus u dv dx, and divide by v square and so on. Okay, so you will get the answer here. So by the Cauchy residue theorem, so integral of this one will be 2 pi I plus your first one times your first one and your second one plus together. Then you will get your answer. Okay. Okay. Secondly, second the questions they said only enclosing z equal to 0, z equal to 2i, but not enclose the z minus 2i. Okay, z equal to negative 2i. Because why they said so? Because here you have z equal to 0. Here you have z equal to 2i and negative 2i. But we're not considering this one because this one is not enclosed. Okay, so we only consider z equal to 2i. So when you find the residue, you only consider these two. Okay, although this one actually is a pole of this one, it's one of the simple pole of this one, but we not consider because it's not enclosed. Okay, so that's why in the 2 here, you can see, okay, we have 0, we have plus minus 2i, okay, but only 0 and 2i is enclosed. So we only need to consider 0 and 2i. Okay, but 0 is, let me see. Okay, 0 is a simple pole. Again, they divide the z lah, so they make 1 there lah. Okay, so they get this answer. Okay, 104, and this is when it is simple pole. Okay, this one is also simple pole. They get this answer. Okay, so by using the theorem, will be 2 pi I of this one plus this one, so they get the answer as this one. Okay, and then for the third case, okay, third case they does not mention which are inside, which are outside. Okay, they just give us this is a circle. Okay, this is a circle, so z minus half. Okay, modulus of z minus half equal to 1. What's mean by this one? So this is a circle. Okay, so how is this circle look like? So it will be something like this. Because you have what? Z minus half equal to 1. This 1 is mean the radius. Okay, so this 1 is a radius, and then this 1, okay, you have to shift your center half. Okay, so you have to shift your center half, maybe somewhere around here. This is your radius. Okay, so this one is half, and then this one will be 3/2 because you have to plus 1. This one minus half, so you have a minus 1, so you have negative half. Okay, so now we have a look. Z equal to 0, Z equal to 1, Z equal to 2. Z equal to 0 is here. Z equal to 1 is in between half and 3/2, so it's here. But Z equal to 2 is outside. So Z equal to 2, we no need to consider. So we no need to consider this one. We only need to consider when Z equal to 0 and Z equal to 1. So this kind of question, you need to find out what pole you have to consider. Okay, O is a simple pole lah, but you have to consider which one is inside your circle. Okay, 0 and 1 is inside your circle, so you find the residue, and then your integration will be 2 pi I times the 2 residue plus together. That's all. Very simple. Okay, any questions? If no questions, try to complete the tutorial 2. Later we discuss together. I'll give you maybe 10 minutes. You try to do first, huh? Hello，怎么了？可以啊，可以啊。我学生有啊，他们只是 Google Meet 啦，有 meet 几次啦，一个 semester 至少好像他们prepare question A 他们会来问我一下，然后 after question A 他们会来问我一下，before data collect 他会来问我一下，after data collect 他会来问我一下，这样子啦，大概这样子啦。中间我也没有帮他们一个一个 check，不过他们有来 consult 我一些东西这样子啦。对，天，哇哇，然后他写出来的东西完全不行啊。这样的话，你有跟 a 艾 e 的讨论吗？是谁？你有看到吗？ 什么名字？我看一下是不是我的，分分钟是我的嘞。我 check 一下，等下啊，因为我有两个，我只写好别人的我只写好一个，还有一个我还没有写，今天才要写。什么名字啊？我才写好 I need sharfa no I need no magia 这样熟的这个名字不是我啦，不过不是我 no magia 哇，那个不是毕业很久了咩？那三个是其中一个是在马拉教书的是吗？不是，I mean 那三个里面其中一个是在教书的吗？那个毕业很久了吗？教书的啊，这样是那三个的其中一个啦。哇，那三个很久了哦。
Hello.
Sorry, okay. Let me see. Okay, sine z. This one is an expansion of what? 1 minute. Expansion of sine z. Not this one. Taylor series, if not mistaken. But 1 minute. Let me check. There are, if not mistaken, is Taylor series or McLaurin series, but I can't remember that. Yeah, this one. You can see here. Just now got one asking why sine x is this one. Is it? This is a Taylor series. McLaurin series and
No.
Taylor series is an expansion lah. McLaurin series, Taylor
Sir,
series is
haven't share.
McLaurin series when x equal to 0. Sorry,
Haven't
I
share
just
the
say.
screen.
Oh, sorry. 1 minute. Sorry, now only I found your questions. Okay, when this one is a Taylor series expansion of sine z. Taylor series is a Maclaurin series. If you are interested, you can have a look on the Maclaurin series. Okay, Taylor series is Maclaurin series when x equal to 0. This is Taylor series lah. If you want, you can have a look on the Maclaurin series also. If not mistaken, it's something like this. Maclaurin expansion. Yeah, this is a formula of a Maclaurin expansion. Okay, when your when your a is 0, okay, when your when your a is 0, then you will have Maclaurin series. Okay, sorry, you will have Taylor series. This is Maclaurin series. So I continue. I have a look at the questions. Yes, sorry. Now I only saw that. Okay. Basically, it's because of the Taylor expansion Taylor series It's not a Maclaurin series but they are almost the same thing. Just one is with the a equal to 0. One is a with other point. But basically, they are the same thing. Done the tutorial.哦，OK OK，因为 Doctor 丢这个我现在才打开来看只有 quantitative 而且好像我没有看完我只是看 abstract 罢了它的 quality 好像不是很好，感觉上这一个应该也是会让人蛮痛苦的。Okay, so I continue. Wrong answer. Which wrong answer? Maybe the answer is wrong. I don't know. Okay, I start with 5-1 Okay, so I want to z conjugate. Z conjugate over the curve defined by zt equal to eit. Okay, so zt equal to eit. I want to differentiate from 0 to pi over 2. So that means now my zt equal to EIT. So EIT, it will be sorry. EIT will be cos, what again? Exponential. Sorry, I can't remember the, what kind of this? Exponential. Okay. So Z equal to R theta I sine theta. So it will become EI theta. Okay, EI theta is okay. So I continue. So this one will become cos T plus I sine T. So that means our dz will be equivalent to negative sine T plus I cos T dt. Okay, so where your T is 0 to pi over 2 lah. So that means now, okay, your this one will be equivalent to, you integrate from 0 to pi over 2, and then z conjugate, because now your z is this one. So conjugate will be cos pi t, cos t, sorry, cos t minus I sine t, because it's conjugate, okay, z bar. And then times with this one. So I will have something 0 pi over 2, and then negative cos t sine t. This one, you will have negative cos t sine t. Later you will have plus uh, plus cos t sine t. So it will cancel each other. I repeat again. This one times this one, you have negative cos t sine t. And then this one times this one, you will have cos t sine t. So it will cancel each other. Okay. So you will only left here is I times your sine square t. Okay. This one times this one times this one, plus cos square t. So which is 1 lah. That means your answer here will only have I and then T 0 pi over 2. So your answer will only pi over 2 I. Yeah. Okay. Have a look and please ask if you have any questions. Okay, so I proceed to the next one. 2, I don't do it. You can try to do. But basically, it's the same. Just it is pi over 2 to 0. So that's why you get negative. But it's the same thing. Okay. So number 6, evaluate this one. Okay, 2z plus 1 dz, where c is the following path, z equal to from negative I to 1. Okay, simple line segment, two simple line segment, and this one. So now we have a look. 2z plus 1. Basically, 2z plus 1 is analytic. Okay, it's analytic. So as long as your initial point and your final point is the same, then no matter you going through which path, you should get the same answer. So for this kind of case, actually you just need to do the 1. 2 and 3 will be the same answer. Okay, so now we have a look for z. Okay, I want to find the z, so we do the x first. So it is from 0 minus I, or okay, 0 minus I into the 1 plus 0I. So for the x, okay, 1 minus 0, so t, and then plus 0, so x equal to t. Y will be 0 minus negative 1, so 1, so will be 1, so t lah, that means will be t as well. So 0 minus 1, 0 minus negative 1, so t, and then plus the negative 1, so minus 1. So that means now your zt will be t plus I times t minus 1. Any questions there? If you have any question, please ask. So how to check this one is correct or not? You put your 0 inside. Okay, you put your 0 inside, you will have 0 minus I. So this is the first point. When you put 1 inside, you will have 1 plus 0I. So you have second one. So this is how we check our parametric equation is correct or not. Have a look, and again, please ask if you have any questions. EIT can. You can direct integrate EIT also if you want. If alamak, I delete it. Okay, you want to direct integrate EIT can. You should get, I write here, integrate of EIT. You should get EIT divided by I. Can, no problem. With condition with respect to T lah. Okay, how to get this one? 0 minus I, 1 plus 0I. Because the question said z equal to negative I. Negative I means is 0 minus I. Because I don't have the real part, so it's 0 minus I. Z equal to 1, and they don't have the imaginary part, so it's 1 plus 0I. I have a look question that's this one, you want to integrate like this, E negative IT, because what I'm doing here, why I make this one into, okay, why I try to make this one into a cos IT and then cos T plus I sin T, because I want to find the conjugate. But actually, if you don't want, you can maintain, okay, Z bar actually is also E negative IT. You can direct integrate this one, integrate E negative IT, E negative IT, but this one is dz. Okay, so what you have to do is you have to find the dz as well. Dz will be I EIT dt. So this one will be times I EIT dt. You can do like this also can. You should get the same answer as well. Okay, but I don't see this one is much easier lah. But I see it's almost the same. So I mean the step lah. Okay, so I do it in the cos and the sine. I change in the cos and the sine. but still okay if you do it in the exponential directly. Okay. So I continue. So after I get the zt, so again lah, we try to differentiate. Tz would be 1 plus I. This one, differential with respect to t, I get I on it. Okay. So this one I get dt. So that means now this one, integrate of 2z plus 1 tz also is equal to, okay, c will be 0 to 1. No more z lah, you have to change your z to here lah. So 2z plus 1, that means you will have 2t plus 2i, t minus 1 plus 1, and don't forget you have to time this one times 1 plus I dt. So this one, I made my 1 plus I outside. Okay, because it's a constant, so I can take out. So I left this one only. I have t squared plus t squared over 2. So t squared I. And then this one minus 2i, so minus 2ti. And then plus t. 0 to 1. So I will have 1 plus I. What is inside? 1 plus 1, 2. And then this one will be I minus 2i, so minus I. So we times inside, I will have 2 plus 1, so 3. Negative 1i plus 2i, so plus I. Okay, have a look. And please ask if you have any questions. Okay. Oh, sorry. I get. Okay, sorry, just now left meeting because of battery. Okay, I have a look again. So x equal to 1. Yes. Hey, wait. Let me check. Yes, correct. This one is correct. This one is correct. What you ask is correct. But you have to remember lah, x is a real part, y is the imaginary part. So when you combine them, you have to make it as z equal to x plus iy. Any more questions before I proceed to the last question in the tutorial 2? X equal to x1 minus what is no. Okay, it's something like this. Z is equal to x plus iy. So what you have in the x is t. So that's why I have t. And then plus I times what you have for the y, t minus 1. So t minus 1. This is my z. And how you get the x? Okay, the x is always the final minus the initial times the t and then plus the initial. This is how we're going to find y, also the same thing. Final minus initial times the t plus the initial. Okay.是明天啦，不是今天啦，星期三才拿车。 Okay, so I proceed. What? Sorry? Yes. But must be remember lah, must be the final minus the initial. Okay, don't terbalik. If terbalik, then you will get negative something. Okay, they will be wrong there. Okay, I proceed to the last one. Okay, so in each of the following, evaluate this one. Okay, fz equal to real part. Okay, and c is the line segment from 1 to 2 plus I. Okay, this one is not concerning about the residue. This is not because what we learn. Okay, I just go back. What we learn here. Okay, we try to find the residue. We try to find the simple pole and so on. Okay, and then easily can get the answer. But here, what we see here, this one we don't have any residue or we don't have any residue is IES. Okay, we don't have residue, we don't have simple pole. Okay, for these two equations. So that's why I cannot proceed with the what we learned just now. Okay, this one I just proceed with normal integration. Okay, so first you have 1 to 2 plus I. So again, that means it's 1 plus 0 I lah. So your x is what? Your x will be 2 minus 1. So it's 2 minus 1 t and then plus 1. And then what is your y? Your y is, this one is 1, this one is 0. So 1 minus 0, so t, and then plus 0, plus 0, no need to plus. So that means what is your z? T plus 1 plus it. Okay, so this is your zt, where your t is 0 to 1. Again, you try to put, when you put 0, you have 1. So this is the first point. When you have 1, you have 2 plus I, which is here. So it should be correct lah. Okay, so I want to integrate this one. Now before that, dz will be 1 plus I dt. So that means integrate of fz dz, it will become 0 to 1. Okay, real part, only the real part. Only the real part, that means only the x, which is t plus 1. And then times the 1 plus I dt. So 1 plus I take outside. T plus 1 because got t, so I cannot take outside as well. So this one I will have t squared over 2 plus t, 0 to 1. So I will have 1 plus I. So I put 1 inside, 1 over 2 plus 1, so 3 over 2. So I have 3 over 2. So this one is my answer. Okay, have a look and try to do a 2.那真的，我再不回我老板，真的是叫我不要，好不好？ Okay, so now we have a look for the second one. Hmm. Okay, so I want to find fz is this one where the zt is this one. Okay, this one's very simple. They give everything already. Okay, so that means your dz, I can just direct take your dz will be 1 minus 2it. That's very simple. Okay, so that means I want to integrate this one. That means will be 0 to 2, 0 to 2, and then your fz is this one. Okay, so just substitute inside. So t minus I t square minus I and then cube and then times the dz. Okay, 1 minus 2 I t dt. So the rest will be the same. What is difficult is, oh, even difficult also don't difficult, because this one you don't need to expand anymore. Okay, you can just let u equal to t minus I t square minus I, and then your du will be 1 minus 2it dt. So that means this one actually is equivalent to 0 to 2 and then u cube du. So that means your answer will be u4. U4 that means t minus I t square minus I and then power of 4 divided by 4. This is 0 to 2. So put inside, then you will get the answer. Okay, put inside, then you will get your answer. I don't know what is the answer. 10 plus 210i. I'm not sure whether correct or not. You can try. But this is the way to do lah. No need to expand. No need to expand the power of 3. Expand until you die also haven't done. Okay. So any questions before I proceed again? If no questions, I want to proceed to the next chapter. Next tutorial. I think the next tutorial is still okay to do. Let me see. Mm, is it? Oh, no more. Then I have to proceed to the next chapter already. So any questions? Just sub 2 into t. Max error? Is it? Let me see. Normally it's sub 2 into the t. Should be correct what? You 4 over 4. 0 to 2. Let me see. So I will have 2 minus this one will be a 4, negative 4 minus 1, so negative 5. 2 minus 5i divided by 4, is it? So you also can, this one is power 4. So you can, up to you lah. You want to use a calculator or you want to expand it manually, also can, up to you. Okay, so 2 minus 5i, power of 4. Alamak, error. Okay, then I only can do it myself lah. Okay, so if I do it myself, then it will become if square. Okay, I do it one by one. So 2 minus 5i square, then you should have a 4, and then minus 20i, okay, and then plus minus 25. So 4 minus 25, so 21. Negative 21 minus 20 I, okay, divided by 4 and square it. So square it. So 21 times 21 minus 20 times 20. Is it? So I get 41. Eight four zero. I. All come different. The answer is 10 plus 210. 210. Let me check a bit. 41. Let me check the answer. See whether it's the answer wrong or what. This one is tutorial 2. Tutorial 2 questions. Got question 10. Tutorial 2. Oh, good question 8. Okay, sorry. This one is question 7. I think they also get the same answer. Never mind, I think the answer is wrong. Never mind, we just follow this one. I get this one lah, and does not get 10 lah, but I get 10 point something. Okay, have a look and please ask if you have any questions. Okay, and then continue question 8, 9, and 10. If you have no questions, go meh? I don't know also why mirror, but how I doing it is I power of 2 and then power of 2 again. Close behind got one more. Got ah. Oh, wait. ID square 4, so I take 2, so 2. Got meh? At the back still got. No more what? I don't understand. What you mean? Got wait, let me check. I put 2 inside, so I will have 2, and then negative 5. Nothing wrong. What you mean? Huh? I don't have t, so it's not a 0. In expression, the I don't have t. The I don't have t. You means this one, is it? This one don't have t, so I consider already. So when I put inside, I have 2 minus I times 2 square minus. Oh, yes. I understand what it means. Thank you. Thank you so much. I thought 0 put inside also 0, is it? It means. Sorry, my mistake. This is really my mistake. This one, when we put 0 inside, we should have plus, thank you, plus I4 over 4. Because when we put 0 inside, it's still half, okay? And then we have negative I4 over 4. Negative, so this one should be minus. Yes, okay? Because it's power of 4, so negative also will become positive. So I4 over 4, it will become I square is negative 1. So this one is equivalent to minus of 1 over 4. So minus of 1 over 4, so that's why this one will become 0. Thank you, thank you so much. So sorry because I just not found that. Okay, so this one should be equal to 10 plus 21i. Thank you so much. Okay, have a look from here to here. And if okay, proceed to the number 8. Okay. Where's my mouse? What is BRB? Okay, can. The rest you try to continue with 8, 9, and 10. Later we discuss. Sorry, I does not found that I have the question 8, 9, and 10. Question 8, maybe you do 3 questions, we do lah. 1, 4, and 7. I think the rest will be almost the same, so I don't want to do so many lah. Question 9, you just do the A and B, you do. Question 2, question 10, do the 1 and 3. Okay, so number 8. Determine the location and type the singularity of each of the following function. Okay, so we have a look again. Singularity. This is a residue. Okay, so when we set singularity, actually is we want to find the pole. Okay, we want to find where is the pole. The pole is very simple. Normally is we're trying to find down there is equal to 0, and then we will get the pole. Okay, so same thing here. So for the first one, E3Z divided by Z minus 2. So very clear. The pole should be, and this is a simple pole. Okay, this is a simple pole. Simple pole at Z equal to 2. And since this is a simple pole, so that means when you want to find the residue, okay, the residue will be depends lah, because this one is simple. So I will just E3Z, E3, and put your Z into the Z, not into the Z, so 2, and then differentiate here, so 1. So the answer will be E6. Again lah, just like what I said just now, we have two formula for simple pole in order to find the residue. Is it? Okay, in order to find the residue, if you are a simple pole, then you can either use this formula or use this formula. It depends on your GZ. It's easy to differentiate or not. If it is easy to differentiate, then you use this one. If not easy to differentiate, okay, then you use this one. Okay, have a look.